In this tutorial, I'm going to cover almost all JavaScript syntax as quickly as possible. I also created the most popular JavaScript course in the world, so if you're new to programming, start there. But if you already have some programming experience or you just want some review, this is the course.
So here we go. There are three ways to define a variable with var, let, or const. They can be strings or numbers or a variety of other data types. Var is the oldest way to declare variables. It's not used as much in modern JavaScript, but variables declared with var are function scoped, meaning they're only available within the function they're declared in. Let is a newer way to declare variables, and they are block scoped, meaning they're only available within the block they're declared in. And const are constants. They cannot be reassigned, and they're also block scoped. So these are all the different data types in JavaScript. We got undefined, null, string, number, boolean, object, and symbol. And then we can do basic arithmetic. We can multiply numbers, divide numbers, we can do a module of the numbers, and all the basic arithmetic operations you can do in JavaScript. We can also assign a variable and then do num++, which means number equals, which just adds 1 to the number, so it's now 6. Or we can do minus minus, which just subtracts 1 from the number, so it's now 4. And here are all the operators you can do: addition, subtraction, multiplication, division, modulus, increment, decrement, that's the ones we just covered, and exponentiation. So the equal sign is the assignment operator. We were already talking about it, but that's how you assign a number or a value to a variable. And after you assign a variable, you can do the variable plus equals 10, which is the addition assignment. So basically, this means x equals x plus 10. This means x equals x minus 5. The equal sign is a comparison operator. Does 5 equal 5? True. Does the string 5 equal 5? True, because it does type coercion. We also have the does not equal. So 5 does not equal 4. That's true. 3 equals signs is the strictly equal to operator. It returns true if the operands are equal and of the same type. So in this case, false. So here are all the other comparison operators. We have the greater than, less than, greater than or equal to, and less than or equal to. And here's the division assignment: x equals x divided by 5. And we already talked about this one: x equals x plus 10. And x equals x times 2. So x is now 25. And here's the logical operators. We have the and sign, which means and where both have to be true. Or we have the or, logical or, which means only one has to be true. Or we have the exclamation point, which is the logical not, which is the opposite of, so opposite of true is false. So true and true is true, true and false is false, because you need both of them to be true. And with the or, just one of them has to be true, and then the not is just the opposite. And this is how you make a comment in JavaScript, and this is how you make a multi-line comment. The console.log function is used to print output to the console, so this prints hello world to the console. And if we have these two variables, a equals 1 and b equals 2, if we do console.log a comma b, it's going to print the string 1 space 2 to the console. Whenever you have a comma, it's just going to put a space in between the elements. Now let's talk about control flow. Control flow is the order in which individual statements, instructions, or function calls are executed or evaluated. So here we're going to set a equal to 10, and now we have an if statement. If a is more than 5, then it's going to console.log a is greater than 5. So because this is true, this is going to evaluate it to true. The code within these curly braces is going to be run. If this was false, if this evaluated to false, then the code between the curly braces would not run. So here's an if-else statement. So if a is more than 5, then it'll run this code within the curly braces. In this case, this will evaluate to false. So if this evaluates to false, we go to the else statement. Else, and then we have another if statement. If a is equal to 5, then we say we console.log a is equal to 5. So in this case, this will run. It's going to log a is equal to 5. Now we have an if, we have an else if, and we have an else. So the else is run if none of the other if statements are true. So we do them in order. So if first we check if this is true, and if that is true, First, we check if a is more than 5, and if that's true, we run this, and then we don't do anything else after that. If it's not true, we go to the else if. If a equals 5, then we run this line of code, and if that's not true, then we go to else. This is if nothing above is true, then we go to the else, and we run this. So in this case, since a equals 4, we'll console.log a is less than 5. This is the ternary operator. So we put a condition, then a question mark, and then what should happen if the condition is true, then a colon, then what should happen if the condition is false. So here's the example. A equals 10, so the result is going to equal, now here's the ternary operator. So this is the condition. If a is more than 5, then this result is going to be equal to a is greater than 5. Or else it's going to be equal to a is not greater than 5. So in this example, it's going to print a is greater than 5. So now we have a switch statement. A switch statement, we're going to have an expression here, and this could evaluate to multiple values. So if it evaluates to value 1, then we'll execute this code, then we'll break out of the switch statement. If it evaluates to value 2, then we execute this code, then we'll break out of the statement. If we didn't have the break here, then it would just go down and automatically run the next code down here. But since we have the break, it won't. And then we have the default. That's what's going to be executed if the expression doesn't match any cases. So here's an example. Let fruit equal apple. Then we're going to check what is fruit equal. Well, if it's banana, I'm a banana, but in this case it's going to be apple. So it's going to log I'm an apple. And it will not log I'm not a banana or an apple because it is an apple. So now we have a while loop. So while this condition is true, it's going to continue executing everything within the curly braces. So here's an example. So we have let I equal 0. While I is less than 5, we'll console.log I. And we have to have something that's going to break out of the while loop. So I++. So that's going to increment I by 1. So every time it goes through this loop, it's going to increment by 1. So it's going to first console 0, 1, 2, 3, 4, and then it'll break out of the loop because once I is equal to 5, we'll break out of the loop, so it will never console.log 5. Here is a for loop. A for loop is going to have the parentheses after the keyword for, and there's always going to be 3 things within the parentheses divided by a semicolon. So the first element is assigning a variable. So let I equal 0. The second element is when we're going to break out of the loop. So we're going to do this loop until I is less than 10. And then the third element after this semicolon is what code to be run at the end of each loop. So we're going to increment I at the end of each loop. So this could go from 0 to 9 because the loop is only going to run when I is less than 10, but within this loop, we have an if statement, and the if statement is if I is strictly equal to 5, we are going to break out of the loop early. So this code is showing how to do a for loop, and how to break out of the loop early. So this is just going to print the numbers 0 through 4 to the console because it breaks out of the loop when it gets to that break sign. So this is very similar, except now when I equals 5, we're not going to break, we're going to continue. Continue means to jump to the next iteration of the loop without running any more code within that loop. So in this case, it's going to print the numbers 0 through 4, but when it gets to the 5, it's going to automatically jump to the end of the loop and not run this console.log again, and then it's going to print the numbers 6 through 9 to the console. Here's another type of loop, the do while loop. So the difference between a while loop and a do while loop is that in the while loop, we check the condition at the very beginning. In the do while loop, we check the condition at the end. So code is always going to be executed at least once. So it's going to run the code within the curly braces, and then it's going to check the condition to see if it should break out of the loop. So here's an example. Let I equals 0, and we are going to console.log the I. We're going to increment the I while I is less than 5. So in this case, it's going to print 0, 1, 2, 3, 4, 5, because it will get to 5, and then it's going to check that I is now not less than 5, and will break out of the loop after 5 has been printed to the console. And here again is the for loop. So like I already said, in the parentheses we have the initialization, what happens at the beginning where we initialize a variable, we have the condition for when it will break out of the loop, and then what happens, the final expression. So here's another example where we're just going to be logging the numbers 0, 1, 2, 3, 4. Now let's talk about functions. A function is a block of organized reusable code that is used to perform a single related action. So let's see an example. We are going to declare a function. We're going to use the function keyword, and then we're going to name the function. This function is called greet, and then we're always going to have parentheses, and then we have the curly brackets, and then we have the code that's going to run. So now when we put this function in our code, nothing happens. But when we call the function, then it's going to run the line of code within our function. So in this case, we're declaring the function greet, and then we're calling the function just like this, and it's going to console.log hello world. So we can call this function as many times as we want, and every time we call the function, it's going to say hello world. So here, we call the function before we declare the function. Well, it's still going to say hello world because the functions are hoisted, which means you can call the function before it's declared in your code. Now let's talk about function parameters. In JavaScript, function parameters are the names listed in the function definition. They are used to pass values or arguments into functions. So in this case, we have the add function, and it's going to accept 2 parameters. And so when we call the function, we can call the function with the function name add, and we put the parameters 1, 2, and it's going to return. So return is what's going to come out of the function, and we're going to return a plus b. So that's going to be, in this case, when we call it with 1 and 2, 1 plus 2 is 3, and so sum is going to now be equal to 3. This kind of looks like the function before, but this is a function expression. So instead of starting with the function keyword, we have a variable called greet, and then we set it equal to the function. It just said the word function, does not have the name here, the parentheses, and then it has the function within the curly bracket. A function expression in JavaScript is a way to define a function as an expression rather than a statement. So this function is assigned to a variable, and it can be used later by referencing that variable. So we're basically, the way we call it looks the same as before. But there is a difference because these are not hoisted. So if we try to call it before it's defined, it's going to throw an error. So this is that function from before, but I want to tell you that this is called an anonymous function. When it just has the word function and we don't put the function name here, an anonymous function in JavaScript is a function that is not given a name. Instead, it's usually used where a function is expected as an argument, such as in a callback function or an event handler. So in this case, it's not a callback function or an event handler. We just assign it to a variable. But in this example, it is. So we have the set timeout function, and we're going to pass in another function as an argument to the set timeout function. So we have this anonymous function that we're putting in as an argument to the set timeout function. Now we'll talk about arrow functions. Arrow functions in JavaScript provide a concise syntax to write function expressions. They are anonymous and change the way this binds in functions. So in this case, we create the greet, and then you don't have to use the word function here. We just have the parentheses, and then it kind of looks like a little arrow here, the equal, and then the greater than sign, and then we have the curly braces, console.log. So now we can call the function just like normal. So arrow functions can also take parameters. So here's another arrow function. We're assigning it to the variable add, a, b, and then we have, this is how we know it's an arrow function, a plus b. So it's kind of a quicker way to write a function that's really useful in some situations. So now the sum equals add a2 or 1, 2. So sum is now going to equal 3. And we have these parentheses, but you don't always even need the parentheses. If you only have one argument, like in this example, you don't need the parentheses. So here's another arrow function. So the variable square is going to be set to this function. It's going to take one argument, x, and it's going to return x times x. When we do square 5, the result is now going to be 25. So let's talk more about the differences between regular functions and arrow functions. One is the syntax. Arrow functions have a shorter syntax compared to function expressions. So here's a comparison. Another difference is the this keyword. In regular functions, the this keyword represents the object that called the function. So in regular function, this dot value is going to be undefined when we call the function here. In arrow functions, this is lexically bound. It means that it uses this from the code that contains the arrow function. So this dot value is going to equal a. Now we'll talk more about objects and how to call functions like this later. Now let's talk about arrays. An array in JavaScript is a high-level list-like object that is used to store multiple values in a single variable. Each value, also called an element, in an array has a numeric position known as its index, and it can contain data of any type: numbers, strings, booleans, functions, objects, and even other arrays. So here's an example. Let fruit, and then we have the brackets on each side to show that it's an array, and this array is going to contain 3 strings: apple, banana, cherry. Now these are all ways to declare arrays. This first one is an array literal. This is the most common way. But you can also use the new keyword along with the array constructor. And then we have the array of method. This creates an array instance from a variable number of arguments. Then finally we have the array from method. This creates a new array instance from an array-like or iterable object. So they're all going to create the fruit array to be the exact same array. Now let's talk about array indexes. In JavaScript, each item in an array is assigned a numeric position known as its index. Array indices start at 0 and increment by 1 for each subsequent element. So we have the array apple, banana, cherry. This is how we access the specific item at that index, and this is going to be the first item, second item, third item. We can also change items in an array with the indexes. So fruit at index 1 is now set to blueberry, and we can log it just like before. The length property of a JavaScript array just tells the number of elements in the array, so it's going to log 3. And we can set fruits.length equals 2, so now it's just going to remove anything after the second element. So the fruits array is now apple, banana. Now let's talk about destructuring. Array destructuring in JavaScript is a syntax that allows you to unpack values from arrays or properties from objects into distinct variables. So in this example, the array of fruits is destructured into 3 new variables: fruit1, fruit2, and fruit3. And the first element of the array is assigned to fruit1, the second element to fruit2, and the third to fruit3. And you can see it logs apple, banana, cherry. You can also skip over elements that you don't need. So we can see we have a comma, nothing, and then a comma. So now we just have fruit1 and fruit2. These 3 periods here, that's known as the spread operator. It allows an iterable such as an array expression or string to be expanded in places where 0 or more arguments or elements are expected. So here the ... fruits1 and the ... fruits2 expand the elements of the fruits1 and fruits2 arrays into individual elements. So then the all fruits is apple, banana, cherry, date. Array methods. Array methods in JavaScript are built-in functions that you can use to perform operations on arrays. The first one we'll talk about is push. This adds 1 or more elements to the end of the array. In this case, we're now adding 2 elements to the end of the array. So it's apple, banana, orange, pineapple. We also have pop. Pop is going to remove the element from the end of the array. So we are removing orange, but when you pop it, you also can assign it to a variable. So last fruit is orange and fruit is now apple, banana. We also have shift. Shift is going to remove the first element of the array and return that element. So we now have banana, orange for the array, and first fruit is apple. And then we have unshift apple. That is used to add 1 or more elements to the beginning of the array. So now fruit is apple, banana, orange. And then we can also unshift 2 items. So we add 2 items to the beginning of the array. Now we have concat. So fruit1.concat fruits2. That's going to combine these 2 arrays, fruits1 and fruits2, to all fruits. So we have apple, banana, orange, pineapple. We can also concat multiple arrays. So fruits1.concat, and then we pass in fruits2 and fruits3. So now we have all of the arrays concatenated into the all fruits array. And then we have slice. The slice method will return a shallow copy of a portion of an array into a new array object selected from start to end. End is not included. So we're starting at index 2, 0, 1, 2, that's orange, and then we're going to 4. The fourth one is mango, but remember the end is not included. So we just have orange and pineapple. And then we have slice. The slice method changes the contents of an array by removing, replacing, or adding elements. It's going to modify the original array and return an array containing the deleted elements, if any. So if we're going to slice 2, that means we're going to remove the element at index 2, 0, 1, 2, that's orange. So now we're just going to have apple, banana, pineapple, mango in the sum fruits array. Now fruits array is going to stay the same, but the sum fruits array now equals this. Now splice to 2, that means we are going to remove 2 elements starting at index 2. So 0, 1, 2, we're going to remove orange and pineapple. So now the fruit is going to be apple, banana, mango, and the removed fruits, which we splice out of the fruit, is going to just be orange, pineapple. We can also add elements with splice. So here we're going to index 2, 0, 1, 2, and we're not going to remove any elements, but now we're going to add orange and pineapple. So now we have apple, banana, orange, pineapple, mango. And here we're going to start at index 1, banana. We are going to remove the element. So we're going to remove banana, but we're now going to add orange. So now we have apple, orange, mango. The join method is used to join all elements of an array into a string. And the elements will be separated by a specified separator. The default one is a comma. So in this case, will just be apple, comma, banana, comma, orange. Or we can put what we want to separate it with. In this case, we have passed in the space dash space. So it's apple space dash space, banana space dash space, orange. We also have dot reverse, which is going to reverse the array. In the sort, it's kind of just going to sort them alphabetically. Technically, it's going to compare their sequences of UTF-16 code unit values, but practically it's going to be alphabetical. Now, you're not necessarily going to want to use sort for numbers because it's going to convert the numbers to strings for sorting. So to sort numbers in ascending order, you can use a compare function. So we're going to do numbers.sort, and we're going to pass in this compare function. The compare function subtracts b from a. If the result is negative, a is sorted to an index lower than b. If the result is positive, a is sorted to an index higher than b. If the result is 0, no changes are done with the sort order of the two values. The indexOf method is used to search an array for a specific element and return its first index. If the element is not found, it returns -1. So the index of banana is 0, 1, and the index of pineapple is -1 because it's not in the array. The findIndex method is used to find the index of the first element in an array that satisfies a provided testing function. So the testing function is large number, and it's going to put every element in the array through this function and test to see if it's over 13. None of the numbers are over 13, so the index is -1. Well, the findIndex found the index. Find is going to return the actual element. So if it's going to find that this number 130 is over 13, and so it's going to return 130. Well, findIndex would return -1 if it's not found. Find returns undefined if it's not found. The filterArray method creates a new array with all the elements that pass the test implemented by the provided function. So the function is going to get all numbers over 13, and so the filtered variable is now going to be an array with 130 and 44. And if no elements pass the function, so in this case none of them are over 13, it's just going to be an empty array. The map method creates a new array with the results of calling a provided function on every element in the calling array. In this case, we are going to get the square root of every number in the array. So root is now 1, 2, 3, 4. You can also use a map with the function you define. So in this case, we pass in an arrow function that's going to multiply every number by 2. The reduce method applies a function against an accumulator and each element in the array, from left to right, to reduce it to a single value. Reduce uses the provided function, which is this function right here in this example, to add up the elements in the numbers array. The function takes two arguments, the accumulator and the current value. So the accumulator is the value returned by the last invocation of the function, or the initial value if provided. And the current value is the current element being processed. So in this example, if we didn't pass in the initial value, then the sum would be 10. But since we pass in the initial value of 10, the sum is going to be equal to 20. Because the reduce starts with an initial accumulator value of 10, then adds each element in the numbers array to this accumulator. The every method tests whether all elements in the array pass the test implemented by the provided function, and it returns a Boolean value. So this is going to be true if every element in the array is less than 40. And if just a single element in the array is more than 40, in this example, it's going to return false. The sum method tests whether at least one element in the array passes the test implemented by the provided function. So this function tests if a number is even, and because at least one element in the provided array is even, it's going to return true. If no element in the provided array is even, then it's going to return false. For each, we'll do something to each element in the array. So we pass in the elements one at a time, and in this example, we're going to log each element. So it's going to log 1, 2, 3, 4, 5. Is array is just used to determine whether the passed in value is an array, and then it's going to return true or false. In this case, it's false because it's a number. The includes method just returns true if that element is in the array, or it returns false if the element is not in the array. The fill method changes all elements in an array to a static value, from a start index, the default is 0, to an end index. So if you just do fill 0, it's going to fill every single element with 0. But if we do 0, 1, 3, it's going to fill every element with 0, starting at the first index and ending in the third index. So this is the first index, and then the second index, but it doesn't do the third index because it's ended at the third index. And the flat method creates a new array with all subarray elements. The flat method creates a new array with all subarray elements concatenated into it recursively up to the specified depth. So by default, it only goes to depth 1. So right in here, the array has one array within the other array. But if you have a more deeply nested array, you can specify the depth as an argument. In this case, 3. There's a depth of 3 arrays, and it's going to flatten out that array. Flat map method first maps each element using a mapping function, then flattens the result into a new array. So it's basically the equivalent of a map followed by a flat of depth 1. But flat map is often useful as merging both into one method is slightly more efficient. And you can also use flat map to interleave different data. So in this case, flat map first maps each string in the array to an array of words with the x.split, and then it flattens the result into a new array. The .from method creates a new shallow copied array instance from an array-like or iterable object. So we create an array from the word hello. You can also use from with a map function. So the .from, it creates a new array from this numbers array, and then the map function is applied to each element in the numbers array. So each element in the new array is twice the corresponding element in the original array. The keys method returns a new array iterator object that contains the keys for each index in the array. So in this example, after we get the keys, which is 0, 1, 2, we use a for of loop. So we can get each key in the iterator, which is 0, 1, 2, and we're going to log each key. So it's going to log 0, then 1, then 2. And the .values is going to just return the value of each element in the array. So in this case, it's just going to be A, B, and C. So we can let value of iterator, so we're going to get each value in the iterator array, and we're going to log it, A, B, and C. The entries method returns a new array iterator object that contains the key value pairs for each index in the array. So iterator is now an array, and each element in the array has the index and the value. So in this example, we are going to loop through the iterator, and for each time we go through the loop, we're going to get the index and the value. Then we can log the index, and we can log the value. So this is going to log index 0, value A, index 1, value B, index 2, value C. And we're going to talk more about how this string works later. JavaScript objects are containers for named values called properties and methods. So here's an example of a JavaScript object. We're going to start in with curly braces, and then we have the key maker value Toyota, key model value Camry, key year model 2020. And you can see there's a comma after each one, and then we can also have a function. So the key is a start engine, and the value is this function, engine started. You can access the properties using dot notation. So car.maker would equal Toyota. We can also use bracket notation, which would be car, and then you put brackets with the string maker inside the brackets. And you can also call the method with car.startEngine with parentheses after the end. You'll see what I mean soon. So there are a few different ways to declare an object. One is the object literal syntax. This is the method we just showed, and so we have the key values like this. But we also have the object constructor, where we're going to do new object, and then we're going to set each key individually. Obj.key1 equals value 1, obj.key2 equals value 2, obj.key3 equals value 3. There's also the constructor function. If you need to create multiple objects with the same structure, you can use the constructor function. So here's the constructor function, and then we create the object by calling new myObject, that's the constructor function, and passing in the values of the keys. So we talked earlier about how to access the properties using dot notation or bracket notation. Here's dot notation. obj.key1 is going to be value 1. Now here's the bracket notation. And then we have the brackets with the key in there. That's going to output value 1. There's a few different reasons why you would use one or the other, but one is that you have to use bracket notation if the key is a word with a space in it. And here's how you can update values. So we've created the object here. Obj.key1 equals new value. We just set key1 to be the new value, so if we log that, it's going to be new value 1. And we can also use the bracket notation to set the new value, and then it's going to output new value. We can also create values that did not previously exist, create keys that previously did not exist. Obj.key3 equals value 3. That wasn't in the original object, but now key 3 is value 3. And we can use bracket notation for the same purpose here. And this is how you can delete a key. So we're going to delete obj.key1, and then if we try to console.log it, it's going to output undefined. You can check if an object exists in an object using several methods. One is the in operator. So key1 in obj. This is true because there is a key 1. Key 3 in obj, that's false because there's no key 2. You can also do it like this. Obj.key1 does not equal undefined. Okay, that's true. Obj.key3 does not equal undefined. That's false. That's another way to check for a key. Another way to check for a key is the hasOwnProperty method, but we're going to use this to demonstrate something else. This is how you would iterate over an object's property using a for in loop. So we have the object and the object, and then each time it goes through the loop, the new key is going to be in the key variable. So if obj.hasOwnProperty key, then console.log key : obj key. So basically, since we are only looping over the real keys, this is always going to be true. Obj.hasOwnProperty key, it's always going to have the property because we're only looping over the keys in the object. And then you can see it's going to output key 1, key 2, key 3 because of this key here that we're logging. And then we have the colon. As I mentioned earlier, objects can have methods, and you call the message just like obj.myMethod, and it's going to output this is a method. You can also use the this keyword in methods to refer to the object. So this.property1 is going to be this property 1 here, value 1. So when we call this method, it's going to say property 1 is value 1 because property 1 is value 1 up here. JavaScript maps. A map is a built-in object that holds key value pairs. It can hold a key of any data type, unlike in plain objects. It maintains the insertion order and provides helpers to manage key value pairs. This is how you can create a new map, and here's how you would initialize a map with an array of key value pairs. So new map, we have the key ID, value 1, key name, value Alice, and if we do map.size, it's going to say 2 because there's 2 elements in that map. We can use the set method to add a new key value pair. So we're going to add a key of age, value 50. If we check the size, it's 4 because we're still using the same map from before. It was 2. Set the ID, it already exists, so it just updated to 2. Now this is how you get a value from the map. So you put in the key and it's going to give the value. If you put a key that doesn't exist, it's going to be undefined. We can also check if a key exists. Map.hasId, true, map.has none, false. And we can delete keys. So delete the age key, and if we delete the none key, it's going to return false. So this is going to both delete and return true or false, depending on whether it exists. And we can check the size. It's now 3 because we've deleted 1. And if we do map.clear, it's now going to be equal to 0. The whole map has been cleared out. We can iterate using for of. So in this case, we create a new map. We set name to Bob. We set age to 20. Now we are going to loop over the map, getting the key value each time we loop through each element. And we can log the key and the value. Again, we'll be talking more about this in a second here. And this is going to log out Bob and 20. And we can also iterate over the map using the keys method. And we can use values. And technically, we probably should have called this variable value, but it doesn't matter what you call this variable here. So we call it key, and it's going to log each one, Bob and 20. We can iterate over the map's key value pair using entries, as in the order it was inserted. So key value, and we can log the key and the value. So it's going to do name Bob, age 20. Sets are commonly used in scenarios where you need to work with collections of unique elements. So a set can only have one of each element. So it can help remove duplicates from an array. If you convert an array to a set and then back to an array, it's going to remove duplicate elements. So in this case, we have 2 2s, 2 4s. We create a new set with an array, then we use this destructuring, these 3 little dots, to convert that set back into an array, and then we have a unique array that's just going to be 1 2 3 4 5. And then we can also check if an element exists in a set, and this is faster and more efficient than checking if it exists in an array. So check to see if mySet.has 3, this is going to equal true. And here are some of the set operations. We can declare a new set, we can declare a set with initial values, and then we can log what's in each set. So set 0 or set 1 has no values, set 2 has 5 values, and you can see them right here. And we can create a set and check if it has a 1, output true. If it has a 6, output false. We can also create a set and add each element one by one, add 1, add 2, add 3. We log the set 1 2 3. And we can delete an element. It's going to delete the 2 from the set, so now the set only has 1 and 3. We can create a set and then check the size. MySet.size, this is going to output 5 because there are 5 elements in the set. We can iterate through a set with a for of loop. So for let value of my set. So this is the variable that we're creating for each time we go through the loop of my set, and this is going to log 1 2 3 4 5. We can also create a set and do a for each loop. So for each value in the set, we're going to log that out. So these are 2 ways of iterating over the set. And we already discussed this, but we can convert a set to an array by using the spread operator. So this is the set, we use the spread operator to convert it to an array, and then we can iterate over each element in that array. We can create a set, we can check the size, it's going to be 5, and then we can clear the set. Now it's going to be 0 with the set.clear. So here we're creating 2 sets, set A and set B, and then we're going to create a union. We're going to create a new set, and first we're going to convert set A to an array with the spread operator. Then we're going to convert set B to an array with the spread operator, and then we're going to create a new set. You can see that there's a 3 in both of these sets, but when we create a new set like this, we now are only going to have 1 3, 1 2 3 4 5. We can also get the intersection of 2 sets, which is a set of elements that are common to both sets. You can get the intersection of 2 sets by filtering one set for elements that also exist in the other set. So we are going to get set A, which we're basically turning into an array. Then we're going to filter it, and we're going to filter it set B has X. We're going to check if set B has each element in set A. Then we're going to convert all that into a new set and put it into the variable intersection. Then we're going to log intersection, first converting it to an array with a spread operator, and this is just going to output 3. So if we change the filter command and put a not sign, then we're just filtering for each element that's not in both sets. And the elements that are not in both sets are 1, 2. So this is how we find the difference of two sets. So this difference is a set of elements that exist in the first set but not in the second set. So here we're figuring out the set difference. The difference of two sets is a set of elements that exists in the first set but not in the second set. So you can get the difference of two sets by filtering the first set for elements that do not exist in the second set. So the set 1, we're using the not here, so elements that are not in set B, and the elements that are in set A and are not in set B are just 1 and 2. We can also get the symmetric difference. The symmetric difference of two sets is a set of elements that exist in either of the two sets, but not in their intersection. You can get the symmetric difference of two sets by getting the union of the two sets and then filtering out the intersection. So we got the union, we filtered out the intersection, and then we got the symmetric difference where we're checking the union, filtering what's not in the intersection. So we have just 1, 2, 3, 5. So that's every element except the 3 because the 3 is in both sets. Now let's talk about string manipulation. That's how we can do things and change strings.
So first we have concat. Concat is used to join two strings together. So we have string 1 concat string 2, and this is going to be hello world. It's going to combine these two strings together. And now we have caret. That's how you can get the letter at a specific index. So index 7 is 0, 1, 2, 3, 4, 5, 6, 7, the W. That outputs the W.
And then we can check if the string includes this substring. And in this case, yes, it does, true. If it didn't include world, it would be false. Then we can find the index of world. So where does this substring start? Well, 0, 1, 2, 3, 4, 5, 6, 7. It starts at index 7. And then now we can slice. So we can slice off a part of the string starting at index 7, ending at index 12, not inclusive, and then it's going to be world. We also have split. So this is going to return an array that's split at this section of the string, this substring. So it's going to be hello, and then it's going to be split at this comma space and world. So that's what we see down here. We also have replace, where we can replace one substring with another substring. So we're going to output hello universe. We also have string.to lowercase, and that's pretty self-explanatory. It just makes the string all lowercase letters. And we have to uppercase to get all uppercase letters. We also can trim a string. That's going to trim any white space at the beginning or ending of a string. So now instead of these spaces, we're just going to say hello world with no spaces at the beginning or end. We can also decide to either trim the left spaces or the right spaces. So it's going to output the string without white spaces on the left or on the right. Now let's talk about string formatting. So how can we format strings? So we did see this a little bit already, but this is called a template literal. So a template literal allows to embed expressions and other parts of JavaScript within the string. So to create a string literal, you have to start with a backtick, and you have to end with a backtick, and then within the string you put the $sign and then the curly braces, and whatever is in the curly braces can be any kind of JavaScript. So in this case, it's going to be the variable. So now we're going to, within the string, we're going to replace this section right here with the name variable and this section with the age variable. Hello, my name is John and I am 30 years old. We can also concatenate strings by just using the plus operator. So the result, string 1 plus string 2, is going to be hello world. And then we already saw the concat operator, string 1, not concat string 2, hello world. Now let's talk about interacting with files and directories. To interact with the file system in JavaScript, you typically use the built-in FS module in Node.js. So this is not going to happen in the browser. This is going to happen on a server or on your computer using Node.js. So first you have to require the module. Again, this is something that only happens on Node.js. You can require the FS module, and that's going to give you access to the ability to interact with the file system. So this introduces a few new things. The FS module, it provides both synchronous and asynchronous methods. So in this case, we're going to create an async function.
Async and await simplify working with promises, making asynchronous code easier to write and understand. An async function, like this one, is a function that returns a promise, and within it, the await keyword can be used to pause the execution of the function until a promise is resolved or rejected. The await keyword can only be used inside async functions, and it effectively handles asynchronous operations by pausing the function execution until the awaited promise settles. So we're creating an async function called readFileAsync, and here's a try-catch block. We're going to talk about that more later, but basically that's a way to deal with errors. And you always want to handle errors when you're working with the file system. So here we are going to await. You can only await something if inside an async function. So in this case, we're going to await for this read file to finish. So fs.readFile, we're going to pass in the name of the file, example.txt, and the type utf-8. fs.readFile returns a promise, so you can use await to wait for the promise to resolve. So we're waiting for the file to be completely done being read, and we're going to put it into the data log file content data. And then we're also going to catch any errors that happened. Again, I'll be talking about error handling more later, but when the error happens, it's going to log the error. And then we have to actually run that function on here, readFileAsync. Reading files in Node.js can be done using the fs.readFile function. So here's just another way to read the file where we're going to pass in the file path into the function name. And then when we call the function, we're going to pass in the file path that we want to read. Writing files can be done with the fs.writeFile function. In this particular function, we're going to pass in the writeFileAsync function. We're passing the file path. When we call it, it's example.txt. We're passing in the content. The content is hello world. So we're going to write to the example.txt, we're going to write the text hello world, and then we can log files written successfully, or we can catch the error. Again, we'll be talking about error handling more in a minute. We're going to log error. We're going to log what the error is. Now, if you want to append to a file, you just do the fs.append file. Instead of writing a new file, this is going to add something to the end of what's already in the file. So in this case, we're adding more content to example.txt. If you want to overwrite a file, you're just going to be using writefile. We already talked about using writefile. We're going to put in the file path and the content, but whenever you use writefile, it overwrites whatever file is already there. You can delete a file with the unlink function. So fs.unlink, you're going to unlink the file path, which just means it's going to delete. And then we'll console.log file deleted successfully, or we'll catch the error here. And then we can use fs.rename to rename a file. We have to pass in the old path, and then we have to pass in the new path. In this case, we're changing from oldname.txt to newname.txt. Those are being passed into the function when we call the function. Here's how we would create a directory. So this function, create directory async, we pass in the directory path that we want to create, and fs.makedir is going to create a directory, and it says recursive is set to true. The recursive option is set to true to create parent directories if they do not exist. It returns a promise that resolves when the directory has been created, and then we can catch the error and log something if there's an error. We can also read directories. So in this case, fs.readdir, we pass in the directory path, and this is used to read the directory content. It returns a promise that resolves with an array of file names. And we can also remove a directory, fs.rmdir, remove a directory. So whatever directory is passed in is now going to be deleted. Now that rmdir only works on empty directories. So if you want to delete a directory with all of its contents, this requires a recursive function that deletes all files and subdirectories within the directory before deleting the directory itself. So here's an example of recursively deleting all the files and directories within a directory before deleting the directory itself. We can also watch files. fs.watch is used to watch changes in the file example.txt. This callback function is called when the file is accessed or modified. The event type argument can be rename or change, and the file name argument is the name of the file which triggered the event. We can also check if a file exists using the access function. So fs.accessPath, we pass in example.txt,
and then it's going to log the file or directory exists, or it's going to return an error if we cannot access it. So we'll say the file or directory does not exist. Okay, I alluded to this earlier, but we're going to talk about error handling. This is the process of responding to and managing errors that occur during the execution of the program. So error handling is typically done using try catch statements. We already saw these before, but basically we're going to try this. We put any code that could throw an error within the try. If there is an error, we'll catch that error, and then we'll put code to handle the error. So here's an example. Try x equals y. Well, y is not defined, so an error is thrown. We'll catch the error, console.log, error.message. It's going to output y is not defined. We can also have a finally block. So here's the try catch block, but the finally is code to be executed regardless of an error. So if there is or is not an error, we'll always execute the code in the finally block. We can also specifically throw errors. Throwing errors in programming is a way to handle unexpected or exceptional conditions. So it can allow a function to indicate that it's unable to process with its normal execution. So we are going to throw a new error. Division by 0 is not allowed. So before we even try to divide by 0, we are going to check if b equals 0, and then we're going to throw the error if the p equals 0. You can also create custom error types. So this is how you would create a custom error type. Class division by 0 error extends error. We have the constructor. Now we haven't talked about classes that much yet, but the constructor is how we're going to build the class, what's going to run every time in the class. And we have division by 0 is not allowed. That's going to be the error, and the name is division by 0 error. So now we can say throw new division by 0 error. And then the way we would kind of use this function, we have to do it in a try catch block because we want to be able to catch that error. So try console.log divide 1 0. We're going to catch the error. If error instance of division by 0 error, console.log error.message, else throw error. So we're only going to log this message if it's the division by 0 error. If not, we're going to throw an error, which is going to basically stop the program. Error propagation refers to the process by which errors or exceptions are passed up to the call stack from where they were thrown until they're caught by an appropriate error handler. So here's an example. We have this function 1 that's going to call function 2. In function 2, it's going to throw an error. So in the try block, we call function 1. So function 1 is going to call function 2. It's going to throw the error, and then it's going to be caught in this catch error, caught an error, error.message. Asynchronous error handling is a bit different from synchronous error handling. In asynchronous programming, because the operations are not blocking, errors can't be caught with a simple try catch block. So there are a few ways to handle errors in asynchronous code. One is with callbacks. So this is the most traditional way, and it takes an error as its first argument. So we're going to read the file, which is asynchronous, but we're going to have the callback function where we have the error. We're going to be looking for the error, and then we're going to pass in the data. So if error, we are going to console.log that there was an error reading the file. Otherwise, we can handle the data that we got from reading the file. Promises have a .catch method to handle any errors that might have occurred in the promise chain. So we haven't talked too much about promises, but with promises, you do something, and then you can do something else, then you can do something else, and then you can catch any of the errors that occurred above that chain. Wait, you can use a try catch block to handle errors, which can make your asynchronous code look and behave a little more like synchronous code. So we're going to have the await right in this try block, and we're going to catch the errors here.
So there you have it. There are still a few things I didn't fully cover, such as classes, but that's basically all JavaScript syntax.